Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems and want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey, everybody. Welcome to Wednesday night math night. I am so excited to be here with you all. I am sorry I missed last week. I was out sick. We had gone to my cousin's wedding in Alabama, like literally in the middle of the cow fields. It was so cool. But I must have caught some sort of bug on the plane. But I am back. We are back and ready to do math on this first day of May. So with that said, like Dr. A said, I am Amy Sink and I am one of the math specialists here at the Learning Liaisons. And I truly love what I get to do here, which is help you feel more confident in mathematics and help you feel more confident in your ability to pass these exams, because really a huge chunk of it is that confidence going into the exam and knowing that you've got this. So that's really why we're here. I do have some practice problems already constructed, and so we will go through those tonight. But as always, if you have things that you've been working through as you're studying that you're really struggling with, drop it in the comment box, and I am happy to add it to an upcoming session. You can drop concepts in the comment box. You can drop exact questions. Or you can find me on Facebook and message me your questions, and I can absolutely include those in the upcoming weeks. That said, I always like to do a little get to know you. It just makes it feel a little less like we're doing this math in front of a computer screen. So let me know in the comment box where you're from, what test are you prepping for, and are you a spaghetti sauce, like a meat sauce or a spaghetti sauce person, or are you more of an Alfredo person, or are you neither and you don't really like pasta? I asked that because tonight we had pasta for dinner, and my husband makes the best meat sauce. But I ended up turning it into $1 million spaghetti. And so it was delicious. I am definitely more of a meat sauce girl than an Alfredo girl. So let me know in the comment box where you're from, What test are you prepping for? And are you more of a meat sauce or a red sauce person? Or are you more of a Alfredo person? Or do you just not like pasta that much? So without further ado, let's go ahead and get started with our first problem. I am going to begin my next week section next week. And if there are things that you want to see me cover in the upcoming weeks, I will add them to this rolling list of questions. So we will be going over questions that are applicable for pre-K through 12. A lot of the problems I try to choose problems strategically that are applicable for everybody, or at least a piece of it is applicable for everybody. So if you see a problem and you're like, whoa, I'm taking the elementary test and that is most certainly a high school problem, I usually will say something during the solve that's like, yo, elementary people, this is for you, because I want everybody to get something out of as much as possible tonight. Hi Hedge, math. You're taking a math exam. Which math exam are you taking? Is it pre-K through 3, K through 12, K through 6, 5 through 9, GK? Which one is it? You like meat sauce and you're from Miami. FTCE stands for the Florida Teacher Certification Exams. And so it encompasses all of the tests I just talked about in the state of Florida. So FTCE is the name for any exam in the state. K-12, fantastic. K-12 math, okay, and awesome. All right, let's go ahead and get started. Hey, Jen from Tampa, GK Math, marinara sauce, red sauce. We are red sauce people here. Hi, Miss Garcia, MTTC, Michigan, K8, and you live in New York. Awesome. As a New Yorker, are you a red sauce fan or an Alfredo fan? Just curious, because it makes it feel like we're more in our living room doing math than sitting in front of a computer screen. All right, let's go ahead and get started with problem number 1. And it already disconnected. If you are new here, my iPad likes to disconnect randomly. Why? I don't know. It just does. And so we just work with it. We just roll with it, because that's just what you have to do when technology is not your friend. So as soon as it reconnects, we will get back. You can't have too much sauce. That is sad. But a good butter pasta, I love a good butter pasta. It's actually like my go-to thing when I'm sick. I'm like, give me the butter pasta. Why? I don't know. Which of the following is not a zero of the function below? So the way this is worded would definitely be for my 7 through 12, 6 through 12 people. However, there are strategies I'm going to use in this problem that are going to benefit everybody. So yes, zeros of functions are absolutely middle school, high school people for sure, really more the high school level. So when we look at this function and we think about zeros, and I'm just going to do a little rabbit trail real quick. If I'm looking at a graph, zeros are where your graph hits the x-axis, right? So if it's a function that is to the 4th power, then I'm looking at a function that has the potential to cross the graph 4 times. Does it? Not always. So it could be a graph that looks like this. 1, 2, 3, 4. It could cross 4 times, right? But it could also do something like this. It could go 1, 2, 3, 4. And only cross the graph twice. It could also do something like this. 1, 2, 3, 4. And it could cross twice, but bounce once. So each of these possibilities lends itself to a different type of zero, right? But in this case, they're not asking for that. They're just asking literally, which of these answer choices is not a zero of the function, which means I'm looking for an answer that is not zero, right? So if I plug in each of these points into my graph or into my function, my equation, if it spits out zero, then that's not my answer because they're looking for an answer that is not zero. So if it spits out zero, then it's not my answer choice, right? Now, I will usually start with either B or C when I'm plugging answers in. Why? Because it allows me to see, do I need to go up a little or down a little? Now, in this situation, going up a little or down a little really doesn't help because it's not like I'm looking for like the price or the or something like that, or like the greatest or the least. I'm just plugging answers in and I'm looking for not a zero. But I still usually start with B or C, just because statistics says that sometimes those are the more commonly chosen answers. So let's start with C. So I'm literally, like I said, elementary people, even though this is not for you, like a common strategy when we're solving math problems, if I don't know what to do, is to just plug the answers in and figure it out, or use the answer choices to help me. So I don't know how to factor this. I don't know how to I can't factor by grouping or anything like that. So I'm just going to plug the answers in. I'm going to erase this because I don't need that anymore. And I am going to plug C into my problem. So f of x equals, and I have a feeling I'm going to need to make this a little smaller because I am going to run out of space. F of x equals 2x to the fourth minus x to the third minus 42x squared plus 16x plus 160. Now, everybody pretty much in the state of Florida gets a calculator if you're taking a math exam. Not everybody outside of Florida gets it, but I am going to use my handy dandy calculator to help me with this. So 4 times 4 times 4 times 4 is 256 times 2 is 512. So this whole thing equals 512. 4 times 4 times 4, that's 4 cubed. 64 minus, now there's nothing telling me that can't stay a minus. It doesn't all of a sudden become a plus because I don't have another negative to counteract it. 4 times 4 is 16 times 42 is 672. 16 times 4 is 64 plus 160. Now I'm just going to plug that entire string into my calculator. 512 minus 64 minus 672 plus 64 plus 160 equals 0. So that is not an answer because it equaled 0, and I'm looking for not a 0. So now I'm going to try B. Why? I don't know. I'm just not doing A, then B, then C, then D. I usually start in the middle. It's just my process. So now I'm going to do f of x equals 2 to the fourth power minus 2 to the third power minus 42 times 2 to the second power plus 16 times 2 plus 160. Now, some of you are asking, would you actually write all of that out on your test? I would, because I don't want to make a computation error because I punched something wrong in my calculator. And so if I write all of that out, then I can see what I'm supposed to punch into the calculator. Now, if I was solving this like paper pencil, and you'll see like I was solving a bunch of math problems today. If I was solving this paper pencil, I would have not, I just dropped my pencil. I would have not punched this entire string all at once. It's just not my style. I like to do one thing at a time and then write it down, and then do one thing at a time and then write it down. But on a test where time is of the essence, I'm absolutely going to do that entire string, and then I would type it in twice just to make sure I got the right answer. So this string, 2 to the 4th power. So 2 times 2 times 2 times 2 is 16, but then times 2 because I have an extra 2 here. That is going to be a common error because people are going to do 2 to the 4th, but then they're going to forget that there's an extra 2 sitting there. So 2 times 2 times 2 times 2 is 16 times an extra 2 is 32. Minus 2 times 2 is 4 times 2 is 8. Minus 2 times 2 is 4, and 42 times 4 is 168. Plus 16 times 2 is 32. Plus 160. All right, let's go ahead and punch all of that into the calculator. 32 minus 8 minus 168 plus 32 plus 160. That equals 48. What does that tell me? That tells me that that is my answer because that is not a 0 of this function. So B is the correct answer. Questions about that problem? All right, let's go ahead and move on to problem number 2. Now, problem number 2 and 3 are similar to this. And then I promise we're getting to some word problems and some other things. But I wanted to show you like a progression of these kinds of problems. So, which of the following are the zeros? So we just did which of the following is not a 0. Now we're doing which of the following are the zeros of this function below. Again, I am going to use my answer choices. I'm going to start by looking to see if I can factor this by grouping. If I can't, I'm going to use my answer choices. Now, some of you may not be comfortable with factoring by grouping. If you're not, then you're just going to use your answer choices and plug them in and see. I am comfortable with factoring by grouping, so I'm going to see if when I split this, if I can factor it and then group it. So I can pull out an x squared from here because they each have an x squared and I'm left with x minus 3. And from here, I can pull out a 2. That's it. So I'm going to pull out a minus 2 just because I want to. So negative 10 divided by negative 2 is 5x. And then 24 divided by negative 2 is negative 12. That did not work the way I wanted it to. When I factor by grouping and it works, I'm going to get the same thing here as I do here. And then when I get that, I can actually group them together and then I have different factors and I can figure out my factors. But in this case, it didn't work. So I can't factor by grouping. So what I am going to do is I'm going to take an option from A or B or C. And like I said, I usually start with B or C. So I'm going to take an option. I'm going to take B. I'm going to take 2. I'm going to plug it in. If when I plug the 2 in, I get something other than 0, it means it's not going to work. So let's go ahead and plug 2 in. F of x equals x cubed minus 3x squared minus 10x plus 24. 2 cubed minus 3 times 2 squared minus 10 times 2 plus 24. 2 times 2 is 4 times 2 is 8. Minus 3 times 4 minus 20 plus 24. 8 minus 12 minus 20 plus 24. Now I'm going to plug all that into my calculator. And I get 0. Now, can I assume that those are my zeros? Yes. I can assume that these are my zeros without looking or testing the negative 3 and the positive 4, but only because when I look at the other answer choices, no other answer choice includes positive 2 as a choice. And so When I notice that this is a cubic function, that means that I'm going to have a maximum of 3 zeros. Well, 1, 2, 3, we've got that. It's not like I can have 4 zeros or 5 zeros. So that said, if another answer choice, A or C or D, included the 2, then I would need to test another point within that. But it doesn't include 2. So I can safely assume that B is the correct answer. Questions about that one? Let's do one more in this like chunk of zeros of functions, and then I promise we're going to move on. Which of the following are the zeros of the function below? Which of the following are the zeros of the function below? So let's go back to the concept that we were exploring earlier with factor by grouping. Let's factor this by grouping so you can see how it works. So x cubed plus 2x squared minus 9x minus 18. Chop it and group it. I'm going to find the GCF of each little section. So the GCF of this is x squared because they each have an x squared, and I'm left with an x and a 2. And over here, they each have a 9. But if I pull out a positive 9, I'm left with a negative x. And I don't want to be left with a negative x. I want to be left with a positive x. So then I need to pull out or divide out a negative 9. So if I divide this unit by negative 9, I'm going to be left with x. If I divide this out by negative 9, I'm going to be left with a positive 2, because negative 18 divided by negative 9 is a positive 2. Now look at the magic that just happened, y'all. This is the same thing as this. That is the power of factoring by grouping. That is the magic we were looking for. So now that they have that in common, I can literally factor that out. So I can pull the x plus 2 out. And what am I left with? X squared and a 9. And that's it. Now I can go ahead and find my zeros. So I have x plus 2, x squared minus 9 equals 0. And if you're familiar with this process, you know that I set them both equal to 0. X plus 2 equals 0. And at that point, I can look at this and see that this is not going to be a correct answer because it doesn't have a negative 2 included. And this is not going to be a correct answer because it does not have a negative 2 included either. But this one has a negative 2, and so does this one. So we need to keep going. X squared minus 9 equals 0. And if you are taking a middle school or a high school test, this should immediately alert your brain to difference of perfect squares. Difference of perfect squares. This is the difference answer to a subtraction problem of perfect squares, something that I can square root. I have x plus 3, x minus 3. If you don't know how I just got that, comment below and I will include a little difference of perfect squares lesson next week. Set both of these equal to 0, and I can already see without doing any more writing that my answers are going to be negative 3 and positive 3. So my answer is B. Now, though, you see why it's so important to test multiple things, Because if I were to plug in this positive 3, like let's say that the whole factor by grouping thing wasn't for me, but I plugged positive 3 in here. If I did that, it would work. But I can't assume that that's the correct answer, because let's take a look at A and B. Like, let's say you didn't start with B. Let's pretend you started plugging answers in and you started with A and you plugged positive 3 in and it spit out 0 because it is a 0 of the function. If you chose A, you would be wrong. But when we compare A and B are the exact same answer, with the exception of the last thing, a positive 2 or a negative 2. So if you chose A, or if you chose positive 3 to plug in to find out if that, like, those are the zeros or not, it would have been wrong. So that's why I caution you, if you're going to use the answer choice method, make sure you're testing everything or at least comparing your answer choices. Questions? All right, let's move on to the next problem. Meredith is building a rectangular garden. She determined that the width of the garden is 3x plus 4, and the length of the garden is 2x minus 3. What is the perimeter of the garden? So this is a problem that is perfect for everybody. You know, if you've been here before, that the first thing I'm going to tell you to do is draw a picture. Meredith is building a rectangular garden. So I'm going to draw a rectangle. And she determined that the width of the garden is 3x plus 4. And the length of the garden is 2x minus 3. Now, what if you flipped those? What if you put 2x minus 3 right here and you put 3x plus 4 right here? What if you did that? It would not change the problem, because when we're finding perimeter, it's addition. And addition is commutative, so it doesn't matter where those numbers are placed. And if we were finding area, we would be doing multiplication. And multiplication is also commutative. And so I would not get hung up on W is always here and L is always here, or W is always here and L is always here. The only time it matters is like in a volume problem, if they've given you 2 and they're looking for a third. But like that is very rare. It really doesn't matter where you place it as long as you're consistent in the process. So they've asked us to find the perimeter of the garden. Remember, perimeter is the distance around a shape, and area is the square units on the inside of the shape. So perimeter is, if I start here and I walk around this garden, how far will I have traveled, right? And so if I look at my answer choices, because immediately some of you are probably thinking, I don't know how you would even find that, because you don't know what X is, you don't know what the number length is. Oh, excuse me. You don't know what the number of the width is. Like, how are you even going to find that? Great question. That's why your answer choices are there. When I look at my answer choices very clearly showcase that they're not looking for an exact number. They're not looking for you to say the perimeter is 48. They're not looking for you to say the perimeter is 72. They're looking for you to find the expression that equals the perimeter. So if I am truly trying to find the distance around the shape, this is also 2x minus 3, and this side is 3x plus 4. So I am going to add all the sides up. Excuse me. So I'm going to start at my dot, and I'm going to do 2x minus 3 plus 3x plus 4 plus 2x minus 3 plus 3x plus 4. Now I am going to look for like terms because I can't add all of these things together. So I'm going to add all of my x's together. And I'm going to add all of my constants or subtract all my constants together. So 2x, oops, that's the eraser. 2x plus 3x plus 2x plus 3x, 2, 3, 4, 5, 2, 3, 4, 5, 5 plus 5 is 10. And then negative 3 plus 4 minus 3 plus 4. If you are not comfortable or familiar with negatives and positives, use the calculator that God provided us. Use the calculator. If you don't have a calculator, well, then you need to be proficient in adding and subtracting negative numbers. So negative 3 plus 4 is 1. It's just like 4 minus 3. And negative 3 plus 4 is 1. 1 plus 1 is 2. Or you could do 4 plus 4 is 8. And then negative 3 plus negative 3 is negative 6. And 8 minus 6 is positive 2 as well. That means our answer is B. This is not intentional. We've had so many letter B's as our answers. That's kind of funny. Totally not intentional at all. All right, questions about that problem? Questions in general? Anything that you want to see me go over in the upcoming week? Remember to keep that kind of in the forefront of your head that we're looking for that kind of stuff. And then let me know in the comment box. All right, let's go ahead and move on to the next problem. Pet Rescue for Life has cats and birds available for rescue. There are a total of 34 animals needing to be rescued. What is the maximum number of cats that need to be rescued if there are a total of 120 feet among the cats and the birds? Susanna, I see you, and I saw that comment last time, and that is actually on docket for tonight. I will also include it because I only have one problem. So I will include it again in the upcoming week. Student error fractions. And Jen, I actually have, do I have a slope problem tonight? Ironically, that would be funny if I did. Kind of, but not really. What exactly are you looking for with slope? Like, what is the slope of this line, or like relationships of lines with slopes, or like all of the above? All right, let's go ahead and go back to our Pet Rescue for Life problem. Pet Rescue for Life has cats and birds. There's a total of 34 animals needing to be rescued. What is the maximum number of cats that need to be rescued if there are a total of 120 feet among the cats and the birds? Two ways to solve this problem. The first thing I'm going to tell you is I'm going to look at the answer choices and see if there's any absolutely ridiculous answers. And there is. Which of these answers is absolutely ridiculous? Which of these answers is absolutely ridiculous? $68. Why is 68 absolutely ridiculous? 68 is absolutely ridiculous because there are only 34 animals that need to be rescued. And they're asking for how many cats need to be rescued if there's a total of 120 feet among the cats and the birds. So if there's only 34 animals, can I have 68 cats up for adoption? No, that's more than the number of animals I have in my shelter. So that answer is ridiculous. And those are the kinds of things that we need to look for. right? Because if you get to this problem and you have no earthly idea where to start, that would be a place to start, right? So this problem is technically a systems of equations problem, of which we can create a system of equations, but we can also solve it using the answer choices. So you know what I'm going to do? I'm actually going to solve it both ways because I think there are those of you in here who need both ways. So I'm going to solve it my way, which is systems of equations, but then I'm going to solve it using the answer choices for those of you who are like, whoa, that was totally over my head. So I know that I have cats plus birds equals 34, right? Like the number of cats that I have plus the number of birds that I have is 34. I also know that cats have how many feet, assuming that like they're a healthy cat? 4. So if I take the number of cats and multiply it times 4, that tells me how many cat feet I have at Pet Rescue for Life. And how many feet do birds have? Birds have 2 feet. So if I multiply the number of birds times 2, then that tells me how many bird feet I have. And I know there's a total of 120 feet at the shelter. Now I can use substitution or elimination to solve. In something like this, I typically prefer substitution because both of these I could easily solve for. So I'm going to subtract B to both sides. So cats equals 34 minus birds. Totally makes sense. But now, if cats is the same thing as 34 minus birds, I can plug 34 minus birds in for cats and solve because now I only have one variable. So I have 4 times 34 minus birds plus 2 times birds equals 120. Distribute. 4 times 34 equals 136 minus 4 birds plus 2 birds equals 120. Negative 4 birds plus 2 birds equals negative 2 birds. You're going to see why this makes sense in a minute. Don't freak out on me yet. Subtract 136 from both sides. Negative 2 birds equals negative 16. Divide both sides by negative 2. And the negative divided by a negative is positive, so birds equals 8. Well, that does not mean that's my answer because they asked for the number of cats, not the number of birds. So now I just need to do 34 minus bird, right? 34 minus bird, and that gives me 26, which is my answer. Now, that was the very algebraic way to do it. Let's do it not so algebraic, and it'll make sense for some of you. So, we already know the context of the problem. I don't need to do that. But if this is the number of cats, then I can do a table to figure out the number of birds because cats plus birds has to equal 34, right? And so if I do 34 minus 8, that would be 26 birds. If I do 34 minus 14, that would be 20 birds. 34 minus 26 is 8. And 34 minus 68, like not even possible. I'm not even going to entertain that as an answer choice. So those are all the possibilities if I have 34 animals. Now I need to figure out feet. So how many cat feet do I have? And how many bird feet do I have if I have 8 cats or 14 cats or 26 cats or 26 birds or 20 birds or 8 birds, right? So cats have 4 feet, birds have 2 feet. Agree? I don't know what your real name is, but your YouTube name is the male 518, and that your comment -34 he made me laugh. It makes me laugh too. As a math like super lover, it makes me laugh. Okay, so if I have 8 cats times 4, that equals 32 feet. If I have 14 cats times 4, how many feet is that? 14 times 4, 56 feet. And if I have 26 cats times 4, that equals 104 feet. And then I'm going to multiply these times 2. 26 times 2. Up. It just switched on me. 52. 20 times 2 is 40. And 8 times 2 is 16. Now I'm going to add those feet together, and I'm looking for 120 feet. So 32 plus 52 is 84. Not the right answer. 56 plus 40 is 96. Not the right answer. 104 plus 16, 120. There's the right answer. So like I said, for some of you, that made more sense than the question before that, right? Questions, comments, concerns. All right, let's move on to problem number 5. Oh, y'all, I was so excited when I made this problem. Like, it's not a hard problem. It's just a unique problem. All right, let's read it together. A local school is creating snack bags to hand out to students at their open house event. They have 48 packs of gummies, 12 granola bars, and 32 packs of crackers. If they want to create identical bags that contain each of the snacks with none remaining, what is the greatest number of snack bags the school can make? Okay, so I want you to think about this and what it's going to look like. I have 48 gummies. I have 32 crackers. And I have 12 granola bars. Now, your first instinct is going to be to choose 12 because the 12, like I could put 1 granola bar in each bag, call it a day, we're done. But if I do that and I put 1 granola bar in each bag, how would I divide my crackers so that I can create identical bags with no snacks remaining? It's not possible. 32 isn't divisible by 12. Y'all, this is an awful lot of words, and I need you to hear me out because some of you freak out when you see words, and I get it. Math is not words. Math is numbers. And some of you go, oh my gosh, too many words, can't solve that problem. You can, I promise. All this is asking for is the GCF. All this is asking for is the greatest common factor. That's it. What are they all divisible by? It's the same. I'm going to list my factors for 12, 32, and 48. 1 times 12, 2 times 6, 3 times 4, and that's it. 1 times 32, 2 times 16, I think. 3, no. 4 times 8, 5, no. 6, no. 7, and we're back to 8. 48, 1 and 48, 2 and 24, 3 and 4, 6 and 8. I skipped 4. Oops. 4 and goodness. 3 and 16. 4 and 12. 6 and 8. Now I'm looking for the biggest common factor, right? Well, 1 is common. 2 is common. 3 is not common. 4 is common. 6 is not common. 8 is not common. 12 is not common. And now we're out. So 4 is the correct answer. I can make 4 snack bags. And that's it. Now, I'm going to have a ton of gummies in those snack bags, but I can only make 4 snack bags. This is a GCF problem all day. Hi, Patricia. Yes, it is 6 p.m. Eastern Standard Time. I am in Orlando, Florida, and so we do it at 6 p.m. Eastern Standard Time. So yes, I will be done very soon. I am so sorry you're missing the front half of it, but join us next week if it works in your schedule. And if not, you can always watch it back on YouTube. But it's not nearly as fun because you're not live and you can't ask questions live, and you don't get to talk to me like this. So it's way more fun if you're live. You're in the Panhandle. Oh, you must be like way over in the Panhandle where like you're in the same state as me, but in a different time zone. So welcome, Patricia. We're almost done, but you can join us next week. We'll be here. All righty. So the answer is 4. Moving on to the next problem. We're going to do a little standard deviation. A theme park survey found that the average age of a park attendee was 42 years, and the standard deviation was 5 years. Which of the following is the best interpretation of this result? The oldest park attendee that day was 62. Most of the park attendees were younger than 32. Most of the park attendees were younger than 47. Most of the park attendees were older than 47. All righty. Yeah, Patricia, I love you people who live in the Pensacola, or live in Pensacola in the Panhandle, but I forget that's part of Florida too, because it's so far up there. Like it literally would take me like 6 to 7 hours to drive to you, probably. That's just so far away. Okay, so when we are talking about standard deviation, the only thing most of you need to know about that is what it behaves like. I can't think of a test that requires you to actually solve standard deviation. And quite frankly, between you and me, if you are studying for a test that's like, you must know how to solve standard deviation, I don't know if I would study that, because it's a long, drawn out process, and the likelihood of you actually getting a problem that requires you to do that is like slim to none. And even if you did, it would be one problem. I would focus my time on something that's like way bigger than that. So all that said, if you understand a general understanding of standard deviation, it would be helpful. So standard deviation is a bell curve where the mean or the average is in the middle. And then you have 1 standard deviation away, you have 2 standard deviations, you have 3 standard deviations, and so on. And then you have 1 standard deviation on this side, 2 and 3. So they said that the average age was 42. So this middle line is a 42, right? And that the standard deviation was 5. So 42 plus 5 is 47. So this is 47 plus 5 is 53. Nope, 52. Plus 5 is 57. And then subtracting, going the other way, 42 minus 5 is 37. Minus 5 is 32. minus 5 is 27. Now, statistics says that about 34% of your data is going to fall here. Now, depending on the graph that you look at or the study that you look at or whatever, they might say it's 34.2 or 33.7 or whatever. Between you and me, I don't remember all that kind of stuff because what I know is I'm looking for a majority. And then this is about 12% and this is about 2%. And like over here are the outliers, right? About 12, about 2, and then you got some outliers. So the oldest park attendee that day was 62. That would be 4 standard deviations away. Do we know that? If you are solving a standard deviation problem, you can automatically cross off anything that talks about the oldest, the youngest, the mediumest, the mode. We don't have data in front of us. Now, if you have the data in front of you, that's different. But in this problem, we don't have the data in front of us. We don't know if there was a 70-year-old there or a 90-year-old there or only a 52-year-old there. We have no idea. All we know is the general distribution of the data. So now, most were younger than 32. Younger than 32 is this group right here. Is that most of the people? No. Most were younger than 47. That would be from here over. Is that most? Most is anything over 50%. 34 plus 34 is definitely over 50%. Most were older than 47. That would be this group right here. Still not most because 12% plus 2% is only 14%. So that is not most. So when we're looking at standard deviation, and this is modeled after a problem on the GK, but when we're looking at standard deviation, we're really looking at trends in data is what I want you to pay attention to, okay? Questions about that? Comments, concerns? What do you want to see me go over in the upcoming weeks? Because the next couple of problems I have are going to actually, no, let's do the student error analysis problem and then we'll talk about that because I promised Susanna that we would talk about student error analysis. So let's talk about that. Okay. A student was asked to compare the fractions 3/4 and 5/8. I'm automatically going to write 3/4 and 5/8. The student stated that 34 is less than 5/8. Which of the following best describes the error in the student's analysis? You're welcome, Patricia. The student did not find a common denominator before comparing the fractions. The student incorrectly compared the numerators without considering the fraction as a whole. The student mistakenly inverted the fractions before comparing them. Or there is no error. The student's analysis is correct. So, when I'm doing error analysis, I'm always going to solve it myself and then analyze it. So I know that 3/4 is absolutely bigger than 5/8. Why? Well, if I have a calculator, I can literally convert them into decimals, and I can do 3/4 equals 0.75 and 5/8 equals 0.625, and it's bigger. But if you don't have a calculator, then that's not helpful. I could also convert this into eighths, multiply both by 2, and I get 6/8 and 5/8. So it shows that it's bigger. But what is the error? The error is not that the student did not find a common denominator, because we don't know that. It does not say that the student did or did not find a common denominator, and it's not necessary in the comparison of fractions. Is it helpful? Yes, but it's not necessary. And so that's not an error because we don't know if they did that or not. They didn't invert the fractions. That That's absolutely not the case, because even if they did 4/3 and 5/8, 5/8 would be great, but like that's not what they did. And there is an error. What the student did, most likely, is that they compared the numerators. So they saw 5 and they were like, that's it. That 5 is bigger than the 3. So it means that 5/8 must be bigger than 3/4. And that is a very common error when students are comparing fractions, is they view the numerator and the denominator as separate quantities without realizing that it's one big quantity or one small quantity. So that would be the error. We will do another error analysis next week with fractions. Before I turn it back over to Dr. A, I am going to look at the comments. While I turn it back over to Dr. A, I'm going to monitor the comments and see if there's anything else that you want me to go over next week. And I will see you guys next week on May 8th. Have a wonderful week, and I will see you next week. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.